Hello and welcome to the Teledyne ISCO Chromatography Lab. Thank you for joining us as we provide an introductory course in flash chromatography. Flash chromatography is a popular technique for purifying pharmaceutical compounds in final organic products. It's also widely used in natural products research. The advantages of automated flash chromatography are many. It's easy, fast, relatively inexpensive, requires minimal development time, uses less solvent to save on cost, and offers more exacting results. There are a number of instruments available for flash chromatography. Today we will use a CombiFlash NextGen 300 Plus, manufactured by Teledyne ISCO at our factory in Lincoln, Nebraska. In addition to the NextGen 300 Plus, our demonstration will involve a dye, which we will separate out into its components. The dye will be injected into a cartridge and placed on the NextGen 300 Plus. Chromatography involves a mobile phase and a stationary phase. Today, we will use a mixture of hexane and ethyl acetate as our mobile phase. The mobile phase will cause the dye to travel down the stationary phase. The stationary phase will be this column filled with silica gel. That's where the separation will occur. First, we will attach the column to the NextGen. Again, this column contains silica gel and serves as the stationary phase in the process. Columns come in a variety of sizes and compositions for a variety of applications. Teledyne ISCO's disposable ReadySep columns for flash chromatography are precision-packed for high resolution and reproducibility. The columns range in size from 4 grams to 8.6 kilograms. Today, we will use an 80-gram silica gold column. Teledyne ISCO columns contain an RFID tag that the Teledyne ISCO unit can read to know what size and type of column is being used. Turning to the integrated touchscreen, since we're using a ReadySep RF gold column, we will select Gold Resolution, which, as the name implies, will give us a better resolution as a result. Now we will select the type of column we are using, which again is a silica 80-gram column. We will run using the default method. Since our sample has been adsorbed onto silica, we will use a ReadySep solid load cartridge to load the sample into the column. Place the sample in the solid load cartridge and press it down using a loading rod. Next, we will inject the sample into the column. We will attach a solid load cartridge cap to assist with injection. And then we will place the solid load cartridge onto the NextGen's column block. Then we will attach a solvent line from the NextGen to the solid load cartridge cap, and our sample is ready to go. Press the Start button on the main screen. Press the Sample Loading menu button and select Solid. Press OK. The NextGen will require a few minutes to equilibrate before it can begin injecting the sample into the column. Once the equilibration is complete, the sample is injected into the column using our mobile phase, the solvent mixture of hexane and ethyl acetate. The bands of color you see are the various components of the dye. Not all components may be viewable to the naked eye. As the concentration of ethyl acetate or the strong solvent increases, it causes the other bands to start moving down the column. Once the compounds in the test sample elute, or separate out, through the stationary phase, the individual compounds are ready to flow to the detector. The prevalent type uses ultraviolet light. Because each compound absorbs a different wavelength of UV light, each compound within the sample has its own signature. Each UV reading is sent to the NextGen, where it's translated into a graph of the sample's components. The UV signal for each component in the sample is displayed as a peak on the graph. Instruments from Teledyne ISCO have the computer and peak track on-screen control built right into the unit, saving lab space otherwise taken up by separate systems. The UV signal is also used to trigger fractionation in test tubes using a fraction collector. When the machine sees a peak in UV, it causes the fraction collector to move to the next tube. Since each compound is isolated in a different tube, when the solvent is evaporated, all that's left is the compound you're trying to isolate. That isolated, purified compound can then be used for developing and manufacturing foods, pharmaceuticals, and many other things. At the end of the run, the system goes through the cleaning process, washing out any fluids and purging remaining air from the system. All waste travels through the system into a designated waste container. And that wraps up our flash chromatography demonstration. This was just an introduction, but we hope it has piqued your interest. Puns aside, if you'd like to learn more about flash chromatography, check out Teledyne ISCO's chromatography blog. To learn more about everything Teledyne ISCO does, go to www.teledyneisco.com. Check the description below for links to our social media pages, and be sure to like and follow us and subscribe here on our YouTube channel. Thank you for watching.